Hassler here. I'm going to work through the 4.1 Explore and talk about a couple ideas from the Check Your Understanding. So in class, students worked on this, which landscaping company at the boards. There are two different landscaping companies, and they're looking to gain clients. Today, we will explore which company is the better option. So Greener Grass Landscaping charges a $120 initial consulting fee and a $55 fee for every time they send an employee to a customer's house. Write an equation to represent the cost C for the company services in terms of V, the number of house visits. And this is very much like that Y equals MX plus B that we talked about in Unit 2. B is that initial amount. M is the rate or that slope. Only I'm going to use C. C is equal to that initial amount, that 120, plus the $55 per visit, V. If the company had to come out to a customer's house 3 times, how much would they charge? So this 3 represents my visits, and I want to find the cost. So I can replace the V in my equation with 3 and do this calculation. And if I type this in, I get $285 would be that cost. So then there's this other place called Flower Power. And Flower Power Landscaping charges an $85 initial consulting fee and $62 every time they send an employee to the house. Same idea. I'm going to write an equation for the cost C based on the number of visits. And so my cost is equal to my initial amount, 85, plus the cost per visit, so 62V. This one says, again, if I'm going to visit the house 3 times, how much will that cost? And so I'm going to use my equation. I'm going to replace the V with 3. And when I do that calculation, I get 271. So if I had to choose right now, I would choose Flower Power to go with because they're cheaper. Not by a ton, but by enough. It says, after how many visits will the companies have charged the exact same price? And what is that price? Show how you figured it out. And what I thought was really interesting is that there are a couple ways you can do this. One, you can just start testing numbers, right? We already tested numbers by substituting 3 in. They were not the same price when I substituted 3 in. I could substitute 4 in, 5 in, 6 in until these outcomes end up being the same. Turns out that I have a graph down here below, and when I look at this graph, I notice that my number of visits is my X, my cost is the Y. That seems reasonable based on our equations. And I notice that I have this intersection when the number of visits is 5. So it feels like after how many visits that my visits will be 5. If I follow this across, it looks like the answer is $400. It could be a little lower than that. So I can figure that out. I'll talk about that in a second. But the other way that we could figure this out is I could take my equation for Greener Grass, and I could take my equation for Flower Power, and I could set them equal to each other, right? So I could say, well, when is 120 plus 55V going to equal 85 plus 62V? And if I solve that equation, if I subtract the 55V and subtract the 85 and divide, I'm going to get 5 visits, which matches my graph. And so if I want to know what that cost is, I could substitute it into either one of these 2 equations. This is where they should be the same, just like I did that in part B's. And so I'm going to say C equals 120 plus 55 times 5. When I do that, I get 395. By the way, I also could have put 5 in here, right? I could have done 85 plus 62 times 5. And if I put it in the second equation, I would get the same number because I'm looking to see when the cost is the same. So when I go back to my graph over here, it seems reasonable that 395, not quite at the 400 level. All right, 4 says both lines are graphed to the right. Label the line that represents Greener Grass and the line that represents Flower Power. And so looking at my equations, Greener Grass has a an initial value of 120. And so greener grass is going to be this dashed line. I'll call it GG for greener grass, which means flower power, which has a y-intercept of 85, is going to be this solid line. So I'll say FP for flower power. Given number of house visits at which the total fees for using greener grass landscaping is more than the total fees for using flower power. And so because the greener grass line is above the flower power for values that are less than 5, it just says give a number. So I could have 1 house visit, 2 house visits, 3 house visits, 4 house visits. I really could have 0. I could just have them out to consult. And I could write this as an inequality, right? I could have visits are less than or equal to 4. Could have 4 visits or fewer. I'm actually going to do that compound inequality, right? I can't have negative visits, so I could have 0 visits. I could have between 0 and 4 visits, and greener grass would be more expensive. So this idea of bringing back those compound inequalities, which I think is pretty cool. And this one says, give a number of house visits at which the total fees for using greener grass is less. Well, greener grass line is below the flower power line for any number that is bigger than 5. So again, give a number means like 6, 7, 8, etc. Or any visit that is greater than or equal to 6, if I want to bring that inequality back in. And really, I don't need a compound here because, I guess I could have a limitless number of visits. And 7 says, give a number of house visits at which the total fees are the same. And again, we talked about that. That's where they intersect. 5, and that is because that is my intersection. So fairly quick lesson, I feel. And let's take a look at this backside then to see if we can put this all together. Take some notes here. So this problem says that Miss Stetcher needs 50 pieces of candy to fill her jar. A fun-sized candy bar costs 32 cents, and a roll of Smarties costs 12 cents. She has $10 to spend. So the graph shows a system of equations, and a system of equations, I could say 2 or more equations. I don't know that we'll be working with more than 2, but we're going to say 2 equations. We're looking at 2 equations at a time, okay? X is the number of fun-sized candy bars, and I have that down here. And Y is the number of Smarties, and I have that right here. Not sure why this extra graph is here. Sorry about that, friends. All right, determine which point A, B, C, or D best matches each description. Before I do that, though, I kind of want to label what these equations are. It will just help me have a better understanding of what's going on. X is fun-sized candy bars, Y is Smarties, and so when I see this equation, X plus Y equals 50, that tells me the quantity or how many candies, okay? So that tells me like the total number of candy that it's going to take to fill my jar. And when I look at this equation here, this to me is looking like prices, right? 32 cents for each fun-sized and 12 cents for each Smartie, and a total of $10. So like this is we'll call it the budget equation. This is dealing with money. What that means is when I'm looking at this budget equation, any point that's on this budget equation are points that help make me spend my $10 in the right way. These points B and C are always going to give me candies and Smarties that spend $10. So if I go back to the other line, my X plus Y equals 50, any point on this line is going to allow me to have the right combination of candies that add up to the 50. Okay, so let's read these descriptions. It says, a combination of Smarties and fun-sized candy bars that fills the jar and fits the budget. And what that means is that I'm looking for a point that is going to be on both of those lines, a line that represents the spending $10 and the line that represents filling my jar. And that is going to be this point C, this intersection. The next one says a combination of Smarties and fun-sized candy bars that is not possible given the constraints, meaning it's going to be a point that doesn't work with my budget. It's going to be a point that doesn't fill my jar. And the only point that fits that description is D. D is not on either line. A combination of Smarties and fun-sized candy bars that fits the budget. It's on my budget line, but it overfills the jar. And so my budget line is this dashed line. We already used point C. So this is going to fit my budget. This is going to work out to give me the $10, but it's not going to fill my candy jar. In fact, if I take a look, this lines up with about 61 on the y-axis. So it's like saying I have 61 Smarties and I can only have 50 pieces of candy. So I'm already over my jar. And so B is going to be the answer here. A combination of Smarties and fun-sized candy bars that fill the jar. So it's going to be on my jar line, but it's not possible with the budget. So the only point we haven't used yet is A. So by default, I suppose it's A, but let's talk about why. This A is on my my total candy line. So this A means I'm going to have points that are going to add up to 50, right? It looks like I have 30 here and 20 here. And so 20 and 30 adds up to 50, but it's not on my budget line. And so if I were to substitute this into the other equation, 0.32 times 30, that's my x, plus 0.2 times 20, that actually gives me 12. It's too much money. And so that is why this is point A. So it says, how many fun-sized candy bars and rolls of Smarties should Miss Setcher buy? And so that is going to be this intersection point. We said C is the one that works. And so let's see, I have 20 fun-sized candy bars, and I have 30 Smarties based on my graph. But it says to explain, and so I want to show you that if I put this into my x plus y equals 50 equation, right, I've got 20 plus 30 equals 50. So it makes that equation work. And if I put this into my 0.32x plus 0.12y equals 10 equation, so 0.32 times 20 plus 0.12 times 30. If I calculate that, I do get 10. So the big deal here is that this point, 2030, works for both equations. Okay, and that is going to be a common theme as we move throughout this unit. Real quick, I do want to talk about 3. That's where my graph went. I should have a graph for 3. And in this graph for 3, we have lines that look something like this. And I'm not going to talk through the entire thing, but you have to read the scenario. They do give you a little bit of information here. I just want to point out, it says, which company has a lower cost per meal? And I just want to remind you that when I'm comparing 2 units, I'm looking at a rate. A rate compares 2 units. And rate, to me, is associated with the word slope. And so in order to answer this question A, we're looking at this idea of slope in order to help us answer the question. So go ahead and see if you can answer problem 3. I have the answer key posted so you can check your answers. And then the homework that goes with this was practice 3.1. It did get put onto 2 sides of a page. I stretched it out so you had room to write. So please make sure you do all 4 problems for 3.1 practice. If you have any questions, let me know.